Hello, in this video I'm going to try and go through with you the derivation for the sum of an arithmetic sequence, which is otherwise known as an arithmetic series. So let's remind ourselves what an arithmetic sequence is. It is a sequence of terms which increases or decreases by a constant amount, or a common difference as we call it. So for example, 1, 2, 3, 4, 5, etc. 4, 6, 8, 10, 12, and so on. However, we can also represent this using algebra. U1 is the first term, U2 is the second term, U3 is the third term, U4 is the fourth term, UN-1 is the n-1th term, and UN is the nth term. So the sum of an arithmetic sequence is called a series, and it's given the capital letter S. And so, for example, in the first one here, this would be the sum of the first 5 terms, would be 1 plus 2 plus 3 plus 4 plus 5. And that's quite easy to do. But what about the sum of 100 terms? That's a lot harder to work out. So we're going to come up with a general formula to work out the sum of the first n terms. Let's take a new screen for that. This is kind of extra material, but it could be good to know. So let's start with writing the sum of the first n terms is equal to the first term plus the second term plus the third term, and I could go on, but I'm going to skip a few, and then I'm going to add the last 2 terms, which is the second to last term is the n-1th term, and the last term is the nth term. There we have them. Now I could write this out again, but just back to front. So I can, instead of writing the nth term last, I could write the nth term first. That's because in addition, the order of the terms doesn't make any difference. And then I'm going to write the n-1th term here, and then I'm going to have the n-2 term there, plus, now here, what term am I going to have? Here it was the second to last, so its opposite is going to be the second term, and here the opposite term to this one was the first term. So here I have a system of equations, equation 1 and equation 2. What I'm going to do is I'm going to add the left-hand sides to the left-hand sides and the right-hand sides to the right-hand sides, and we're going to see what we get. So add side for side. So I get Sn plus Sn, the sum to n terms, plus the sum to m terms is just what? It's just twice the sum to n terms. It's fairly simple. Then I get, and now I'm going to do a bit of a trick here, I'm going to add this term to this term here. u1 plus un, and put it in brackets. Then I'm going to add this term to this term here. I get plus u2 plus u n minus 1 plus u3 plus un minus 2 plus dot 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 plus, let's just take the last one, skip out this one, u1 plus un. Now we see what's happened. We've got at least two terms which are identical. We've got u1 plus un here, and we have another u1 plus un here. So these two are going to simplify. But what about these two here? From the definition of, you remember, un, the nth term in an arithmetic sequence is given by u1 plus n minus 1 lots of d. I can express, I can express u2 as u1 plus, n here is 2, so n minus 1 is 1 lots of d is d, plus the n minus 1th term, which is u1 or rather the n minus 1th term is the nth term, subtract 1 lot of d. So what do we have here? We have a u1 plus a un. Likewise here, this term here simplifies to u1 plus 2d, and then plus the n minus 2 term is plus un, the nth term, take away 2 lots of d, plus, and then we've got that last term again. So what we see is we have u1 plus un here, plus u1 plus un here, plus u1 plus un here, plus u1 plus un. So for as many terms as we have in our series, i.e. for the n terms, we have n lots of u1 plus un, because they all simplify to u1 plus un. So we end up with twice the sum to n terms is equal to n lots of u1 plus un. So to get the sum to n terms, I just have to divide all of this by 2. So the sum to n terms is n lots of the first term plus the last term added and then multiplied by n in brackets, divided by 2. So that's all you need to have to know. And you might also see this written in the form. If we replace un with its definition, this would be, for arithmetic sequences, u1 plus u1 plus n minus 1 lots of d divided by 2. So you might also see this as s, the sum to n terms in an arithmetic sequence, n lots of 2 u1 plus n minus 1 d all over 2.